think I messed up. You know that feeling when you realize you've been looking at something the wrong way your whole life? That's me right now, with heat. I always assumed heat just sort of moved from hot things to cold things, in one simple straight line. But it turns out, the science of heat transfer is way more fascinating and a lot more complex than I ever imagined. I used to think heat only moved in one way, but there are actually three. That's right, three totally different ways that heat can travel from one place to another. And each one is happening all around us, all the time, whether we notice it or not. If you've ever burned your hand on a mug or wondered how your food heats up, you need to hear this. Let's start with the first way, conduction. This is probably the one you've experienced the most, even if you didn't know its name. Conduction is all about heat moving through direct contact. When two objects touch, heat flows from the warmer one to the cooler one. Think about grabbing a hot cup of coffee. The mug feels warm, right? That's because the heat from the coffee inside is traveling through the mug and into your hand. The molecules in the mug are vibrating faster because they're hot. And when you touch it, those fast-moving molecules bump into the slower ones in your skin, passing on their energy. The heat moves straight from the cup to your hand. That's conduction, or heat transfer through direct contact. It's the same reason why a metal spoon left in a pot of soup gets hot, even if only one end is in the soup. The heat travels along the spoon, molecule by molecule, until it reaches your fingers. It's also how a frying pan gets hot on the stove. The burner heats the pan, and the pan heats the food. But what about when you're boiling water? That's where the second type of heat transfer comes in, convection. Picture a pot of water bubbling away on the stove. The water at the bottom gets hot first because it's closest to the flame or the heating element. As it heats up, it becomes less dense and rises to the top, while the cooler, denser water sinks down to take its place. This creates a constant cycle, with hot water rising and cool water sinking. That's convection, where heat moves through liquids or gases in a rolling, swirling motion. Warm air from a heater is another perfect example. When you turn on a space heater in a cold room, the air right next to the heater warms up first, rises toward the ceiling, and pushes the cooler air down. This sets up a convection current, circulating warmth throughout the room. It's why the air near the ceiling is often warmer than the air near the floor. In fact, convection is the reason hot air balloons rise. The air inside the balloon is heated, becomes lighter, and lifts the balloon up into the sky. Nature uses convection too. Think of ocean currents, wind, and even the weather patterns that bring us rain and snow. Last but not least, radiation. This one's a little different because it doesn't need anything to travel through. Not air, not water, not even a solid object. Radiation is heat transfer by invisible waves of energy, called infrared waves. You ever feel the sun's warmth on your skin? That's heat traveling through invisible waves, even though the sun is super far away. The energy leaves the sun, travels through the vacuum of space, and reaches Earth, warming everything it touches. That's why you can feel warm standing in sunlight, even on a chilly day. You can also feel radiation from a campfire. Even if you're not touching the flames, you can feel the heat on your face and hands. That's those invisible waves carrying energy straight to you. Microwaves also use radiation, sending waves straight into your food to make it hot. The microwave oven produces electromagnetic waves that jiggle the water molecules in your food, heating it up from the inside out. That's why your leftovers get hot so quickly. So conduction is heat by touch, convection is heat by movement, and radiation is heat by waves. Each method has its own unique way of moving energy, and together, they explain almost every way you experience warmth in your daily life. Next time you're warming your hands by a radiator, watching steam rise from a pot, or just enjoying a sunny day, you'll know exactly what's happening. You're witnessing the science of heat transfer in action. Now you'll spot these everywhere, in your kitchen, your classroom, and even outside. From the way your toast browns in the toaster, to the breeze that cools you off on a hot day, heat transfer is at work, shaping the world around you. Science is literally heating up all around you. Stay curious, keep asking questions, and remember, the next time you feel warmth, you're experiencing a little bit of physics in action.